to apply the actual SSH to the Telnet line, we're going to go back into line 04. Now what we're looking for here is transport. So the transport input, bring down the list here. We're going to set the transport input, define which protocols you can use in connecting to the terminal server to SSH. Now by default it's going to allow all protocols. If I specify SSH, you can see that I can also specify others as well. I just want to use SSH. So if I do this and I try and telnet in, it's going to refuse that connection. And I'll actually demonstrate that. Try and telnet in here real quick. So we'll go ahead and exit out of this and try and get back in via Telnet, and that connection has been refused. Now if we try and Telnet with SSH, brings us a prompt. It shows this is the host key fingerprint. I'm not going to add it, but I'm going to continue on here. And what we'll do is start viewing the packet capture in Wireshark again, and I'll just show you some of the fundamentals here of SSH, and showing that the packets that normally would be clear text have been encrypted. So I'm going to import my username, Matt, and password of Cisco. It's denied me here. Well, one of the keys in creating SSH here and using the local database is you have to set up a local database. So I'm going to add my user, Matt, the privilege level of 15, and a password of Cisco. Now we shouldn't have any trouble logging in here. And there we go, we are in. Back into the prompt there, and if I bring up Wireshark here, you can see all these SSH encrypted packets, and when you bring up the SSH protocol section of that particular packet, you can see it's very well encrypted on both ends. So there's no way anyone's going to be able to get through that and see the configuration commands or your passwords that are going through. So again, SSH, people, they say it runs slower. Version 2 is going to run slower than 1 because 2 is a much stronger encryption method. So one thing we need to keep in mind here is that security is not about convenience. Actually, it's about inconveniencing the people that are trying to break in. It's about inconveniencing almost everyone, but it's the price you have to pay for a secure network, and every network has to be secure. Another way that we can go about by filtering who accesses our Telnet server, or who even attempts to get in to bring up a prompt, is by setting up an access list and applying it to that Telnet interface. So we'll go ahead and do, let's say we have on the subnet, the 2.0 subnet, there's going to be two computers, the .1 and .2, the management stations that we want to allow out of that entire subnet to have access to this. You can see currently I'm assigned the .100, so this shouldn't work if I try and set up this list by doing IP access list. And I'm going to create an extended access list with the name SSH management. With one line we can accomplish this. I'm going to go ahead and do permit any IP protocol from a source address of 192.168.2, the .0 network, and we use a source wildcard bits of 0.0.0.2. The .2 means that the first three addresses, 192.168.2.0, 1 and 2, so 0 through 2 is 3, is going to allow connection requests from those first three IPs, and since .0 is not a valid IP, essentially it's only going to allow a connection from the 192.168.2.1 and .2 IP addresses. The destination address is going to be any. We'll just set that to any. And it's just that simple. The implicit deny at the end of that ACL is going to deny any other request.